All right, here we are in section 3.2. This is graphing linear models. Okay, so we are back in the packet. So go ahead and find this page if you haven't already. And what we have here, this number one, it says state the complete rule of 4 for linear models. And the author of our textbook, he just comes up with this rule of 4 that means that you can describe different things, for example, like the linear model, like what we're doing, in 4 different ways. So linear model, that just means like what we were doing yesterday, the story problem with the linear equation. Okay, so we have, or sorry, maybe that was 2 days ago. Let's see. We can describe a linear model with, so the day I'm thinking about, it was like the Harry Potter book and there was the golfing one. Remember those? That was a linear model. So we described it in a few different ways. First, we could use an equation. Can you think of any other ways? We used a table and a graph. And finally, we could describe the linear model using words. So you won't have to memorize this or anything. I just don't want you to be thrown off in your book if you happen to see this. It's just that you can describe a lot of different math things in 4 different ways: an equation, a table, a graph, or words. Okay? Number 2, this one will not make any sense yet, but it will by the end of today. When using, it's called unit analysis. We determine the units of the expressions on both sides of the equation, and they should be the same. Again, I know that makes no sense at all right now, but it will very soon, in like 5 or 10 minutes, okay? Number 3, let's see. For number 3, we have any equation that can be written in the form y equals b, where b is a constant, has what kind of graph? Okay, so in this one, there's no x. It would just be y equals a number. So, for example, if you just had y equals 3, y equals something is always going to be a certain type of graph. I'm just going to sketch really quick off to the side here. So that's x and this is y. And if I wanted to graph y equals 3, I would go to the y, go to the y-axis, go up 1, 2, 3, and it would be right here. It would be a horizontal line. So any equation that's in the form y equals b, where b as a number has what kind of graph? It's going to be a horizontal line. And what do you think about the next one? Now it says any equation that can be written in the form x equals a, where a is a constant, has what kind of graph? What do you think? Yeah, it's just the opposite. It's going to be a vertical line. So for example, if I do another little sketch, just randomly I'll say x equals 3. You would just go to x and then go to the 3 and then put in a vertical line. That is not vertical. Let's try that one more time. It's a little bit better. Okay. So there we go. Last one here on this page says, what is a linear equation in 2 variables? And we know some examples here. One that we worked on yesterday was y equals mx plus b. Today we just now learned a couple other ones. We learned y equals b and x equals a. So those are just some examples of a linear equation with 2 variables. And just to summarize, we have the graph of the equation is a line. All right, cool. Now on the next page, I think I have 2 problems. I have x equals -4 and y equals 2. So go ahead and hit pause real quick and try to graph both of those problems and come back when you're ready. All right, so I have my x and my y, and I'm going to -4. So I'm going to go to x to the -4. Remember, anytime it's x equals something, it is a vertical line. So I'm going to go over to -4 and just make a nice big vertical line and put little arrows on the ends to show that it keeps on going. So I went over to -1, 2, 3, 4. All right, awesome. Next one, y equals 2. So remember, this is the x, this is the y. And anytime we have y equals something, it's just that number, it's a horizontal line. Added. So I'll go up to, it's positive 2, right? Yeah. So let me get to 2. And put arrows on the ends. And that one's done. Awesome. We are moving right along. Okay, so this, we've got a lot going on here. So this, we're going to take quite a while to work through this one problem. And then what I'm going to do is these other 3, I'm just going to post the solution. So I'm just going to let you work through those and then check out the solutions. Okay, but this first one we will do together. So a person earns a starting salary of $24,000 at a company. Each year receives a $3,000 raise. Wow, must be nice, right? Okay, so then let S be the salary in thousands of dollars after she's worked at the company for T years. Okay, so complete the table to help find an equation for T and S. Show the arithmetic to help you see a pattern. So I have the time in years T. This is my independent variable. That sounds good. Salary is S is my dependent. That all looks great. So now I'm sure that you can look at this and just quickly fill that out. But what's a little bit challenging is trying to generate that equation. So I'm going to go a long way just to show you how you can use this table to help you generate that equation. So she started with the 24,000, right? So I'm going to put in 24 and then added how much every year? 3,000, right? So I'm going to put in a 3. This part looks kind of silly, but I'm going to do it so that it helps me come up with the equation. So 3 times the 1 year. And if I actually do that math, I would get 27. Now say it's been 2 years. Starting salary was 24 plus 3,000 a year, but now it's been 2 years. So now I have 24 plus 3 times 2, I get 30. Next, I have 24 plus 3 times 3 for 33. And finally, I'll fill in that 4. Now, what's happening here is we want to look and see what's changing, because whatever's changing is our variable. It varies, right? That's what a variable is. So do you notice every single line we started with 24? Yeah, so let's go ahead and put 24. That was staying constant. Every single time we had a plus. Every single time we put a 3. And now the next number was changing, right? That was our variable. And if you look, the variable that we were using in each of those was T, right? So it's 3 times T for whatever the year is equals, then we had another one that's changing. What we were calculating when we were doing that is we were calculating the salary. So a little S. I'll try to make it look like an S. I don't know about you, but my S's look like 5s a lot, so I try to write them slow. All right, so we have an equation. So now this unit analysis, I'm going to take that equation, I'm going to rewrite it, just because for a lot of people, they like to see this single variable on the left. So I'm just going to rewrite it as S equals, I'm going to put 3T plus 24, just to put it in that Y equals MX plus B form. You don't have to do that. So this unit analysis, you will never see this on a quiz. You will never see this on a test. I'm only showing it to you because it does show up in these multi-step problems in MLM online work, okay? So I don't care if you cannot do this without looking at a different sample problem, okay? That's totally fine by me. You will not have to do this in a testing situation, okay? So here's what happened. This is kind of weird. On that very first page when I said this isn't going to make any sense at all, it was talking about that the units that we want it to be the same. Okay, so here's what's happening is that we just look at how we would label these different parts. So for example, for S, when we were talking about salary, to label salary, I would write dollars equals. This next part, this is the hardest part. Whatever is before the variable is the hardest one because it's a fraction. That 3 was changing. It was a rate, and it was dollars per year. And when we write when we say per, that means a fraction bar. So dollars per year would look like this. Dollars per year. Okay, so that is the hardest one. Times T. What was T? T was time. And the time that we were talking about, the label was year. Since I'm multiplying it by a fraction, I'm going to write year over 1. Plus that 24, we're talking about dollars again, because that was her starting amount. So now what happens is we look at this and we see, oh, well, we had year on the top and year on the bottom. So what happened is we have dollars here on the left equals dollars plus dollars, which would just be dollars. And then we would just say that the units are the same on both sides, which suggests that our equation is correct. I'll write that down for you. Okay, so it's just kind of like supposed to be a way that you could check that you were on the right track with your equation. You know what, I'm going to do it wrong real quick, just so you could see what would happen if it was wrong. That might help. So say, like, this is not good. Okay, so I'm going to do it wrong, and then I'm going to erase it. Say if I thought that the equation was somehow S equals 3 plus 24t, so this is wrong. If I went and did my unit analysis, I would have dollars equals that 3. Remember, that was my rate, so it would be dollars per year plus my dollars times my time is year. So do you see here in this case, I can't cross anything out. I have dollars equals dollars over year plus dollars times year. We do not have the same answer on both sides, which means that the equation is wrong. Okay, so do you see that? That up in the first one, way up here, we ended up with dollars equals dollars because our years canceled out. So that suggests that our equation is correct. Okay, so that has the correct setup because we got the same labeling of the same expression. Okay, so I'm going to erase all this wrong business here. And let's see what we're doing next. Oh, graph the equation by hand. Okay. So for that one, let's go ahead and start it off together. I remember I always put my title first. I'm going to put just years at company. And across the bottom, my chart only went to 4, so I'm going to make it nice and, well, no, I'm not. I was going to space them out, but I can see that when I did this last time that I didn't quite have enough room, so I will just go ahead and just squeeze them all together. And I don't even need that many. That was time at company. So I got my little T. I'm going to write time at company. And then in parentheses, write in years. And then up the side, I have the salary in thousands of dollars. And that one, the lowest was 24. And then the highest, it went up to, looks like we have 36 on there. So you know what I'm going to do? Since the lowest is 24, I'm going to try this. I'm going to try putting one of those breaks so I don't have to label 0 through 24. That won't always be the best idea, but in this case, it's safe. Okay, there's going to be a problem later on in this packet where you want to include a little bit more of a number. You'll see when we get to it. Okay, it'll make sense later. Okay, so I put in my break because I want to start at 24. Now I can label this however I want, right? I can go up the side as long as it's the same consistent scale. So I have to pick, do I want to count by ones? Do I want to count by two? Do I want to count by fives, by eights? You can count by whatever you want. It just has to be the same spacing. So you can't say like, here's what you can't do. You can't go, oh, I want 25 and then I want 28 and then I want 30. That's going to be a mess. You do not want to do that. Okay, so I'm going to cheat. Well, not cheat. I'm going to do it a slick way. I'm noticing in my table that it went by threes, and it's going to be super easy to graph if I just count by threes because it will line up perfectly on those grid lines. Okay, so I'm going to go 24. I'm going to count by threes. All right, so I have my title. I labeled everything. Oh, I didn't label everything. I didn't put my little S. There we go. Now I've labeled everything. So now you can go ahead and do this part. Plot those ordered pairs, label them, connect them with a line, and put arrows on the ends of your lines. And then try to answer those two questions down on the bottom. Okay, so hit pause and do all that, and I will work through it right now as well. Okay, so I plotted my points. If you aren't quite there yet, just hit pause. Plotted my points. I labeled them, connected them with a straight edge, put arrows on the ends of my line. All right, looks good. Now, for part D, it says, what is the S-intercept? So S, that's that vertical one. And what does it mean in this situation? So the S-intercept, whenever they ask you about a point on the graph, you want to list it as an ordered pair. Okay, so the S-intercept is at that 0, 24. And what does it mean in this situation? That means that the starting salary is $24,000. All right, and last one. When will the person's salary be $42,000? Explain by using arrows on your graph. So, 42,000. I'm going to go up to 42 on my graph. And I'm going to come over. It says to explain by using arrows. In your book, they do like a very serious, like this one has to be dashed and this one needs to be solid. And I don't care how you do it. Okay, so I'm just going to go dashed. If you want to go solid, go for it. I'm just going to walk my way over from 42 until I hit the line. Because once I hit that line, that's my answer. Okay, so it's going to hit 42,000 at, and then I'm going to look down and see where was that at. The 6. So about 6 years. All right. Awesome. So if we were in the classroom, what we would do now is I would say, okay, go ahead and try the next problem. And then as you were working, I would be slowly revealing the solutions. And there's 3 problems. And whichever ones that you didn't have time to get to in class, I would ask you to go home and finish. So right now, go ahead and try this next one. Okay, but I'm not going to make you listen to me slowly talk through it. I've already posted the solutions in that Canvas module. So just pop that open when you think that you've done. I would probably check in like once you get through part B, because I don't want you to do all this graphing if your table is incorrect. Okay, so just slowly work through my solutions and check your work as you go. All right? All right, sounds good. Another fantastic day. I hope you have a good one. Bye.